Sweet, what the hell are you doing? Get back in the lab. Greetings, the Astro 30 here yet again, and I'm currently in the middle of assembling this new PCB of my power amplifier, the 25 watt average, and it's Christmas Day, so Merry Christmas. And yes, I'm doing electronics because, well, I hate going out on Christmas Day, so this is what I'm doing. Anyway, I want to bring up a point someone left as a comment on my previous video about the DC offset of this amplifier. Now, what I did to lower the DC offset was increase the feedback resistor, so effectively reducing the negative feedback back into the long tail pair. Now, someone made a comment that adjusting the DC offset of an amplifier is all about balancing the input stage, or the long tail pair. Now, this is a valid point, okay? It is to do with the input stage as well. Let's get that clear. Now, he said if you have a 22k ground resistor or input resistor here, it's more like 33k because we're going through this 1k as well, but for all intents and purposes we'll say 22k. Then the feedback resistor on the other side needs to be 22k also. Yes, this is a valid point. And next, you would put a potentiometer between these two emitters here, between the current source, and you would adjust it to adjust out the DC offset by lowering the amount of current draw or current flowing through the input stage. That's also a valid point. He also said something about matching the input transistors, or matching all the transistors in the amplifier. I mean, for a project like this, if you want to be so anal about matching the transistors and spending all day with a curve tracer and that stuff, and getting their betas of the transistors exactly matching and all that other stuff, and the reverse breakdown voltages of the transistors and all that sort of shit, if you want to do that, that's fine. Two things: I don't want to do that, and two, I don't have a curve tracer, so matching transistors is not going to be a thing. However, when all is said and done, I'm pretty sure that what I did by reducing the overall negative feedback to the input stage was the right thing to do. Mainly because of those two reasons, that I don't want to spend all day matching transistors, and I don't have a curve tracer in order to do it. So I'm in the process of assembling this new power amp module. I've got all the low profile resistors on and the link wires, and I didn't damage any traces this time. So now I'm just going to go about and put on all the other hardware and components and stuff, and mount it to the heatsink, which I've now drilled 4 holes either corner of it. So here, here, and 2 at the bottom, just so I can mount it to the mounting rails of a rack case. And I have ordered a new rack case. Unfortunately, it was yesterday. So that was the 24th of December. So I don't expect to see that until sometime in the next 2 weeks. Anyhow, so that's what I'm going to do. And then what I plan to do is, after I've tested it on a DC power supply, is I'm going to hook it up to the 18 0 volt 18 transformer to rival in that test amp that I've got. Connect up its power supply, its speaker protector, the preamplifier and everything, and I'm going to test the whole entire amplifier circuitry basically on alternating current. So that's going to be my task for today. And I'll take a few measurements here and there and film bits of it. I'm not going to film assembling it because, well, I've already done that once, there's no point. So anyway, I'll check back with you when I've got this fully assembled and mounted to the heatsink. And a couple of hours later, probably about 3 or so, I've had breaks in between. the power amplifier module is assembled, and I've mounted it to the rack mount case rails for no apparent reason. Just I had a couple of spare ones from another case which will fit the case that's coming. Whatever, might as well mount them to it. I just wanted to check the alignment of my drilling, or the measurement here that I've got, up against the other rack case, which is the same size that I ordered, to see if it would fit the slots that it's supposed to, and it does, so everything's all cool there. Now I've got my power supply set to 24 roughly plus minus volts, which is roughly what the voltage is going to be from 18.018 after rectification, smoothing, etc. And now I'm going to adjust the bias pot, which is now a little bit more awkward to get to with that rail in the way. But anyhow, so we're on the voltage scale, across the fuse holder, across a 470 ohm resistor. I'll turn my load on, and we've got about 6 volt there, so I'll see if I can get my screwdriver in there to turn it. So I'll turn him up, and hopefully, if the screwdriver would stay in there, it would be nice. We've got 6 volt now. I've gone back to the TIP 35 and 36C transistors respectively, because, well, they're a better transistor, to be honest. There we go, starting to climb now. We're at 9, we want around about 11, somewhere in the ballpark of 11. 11.5, somewhere there. Oh, that is very close. This has the same problem as the other one. It's very touchy. There. That's where I'm going to say that the bias should be. So I'm going to leave it at around about 11.2 volt. Seems good enough to me. So what I would do now is I would leave this sit and run just with no load connected and no input signal. Just let it run for about, 3-4 minutes, just so that the heatsink and the VBE multiplier can warm up and the voltage will drop slightly, and then we readjust the bias slightly to bring it back up again. Now, with these driver transistors and the VBE multiplier, the legs only just touch the solder pads underneath. Only just. That means my measurement here is off. I should have made them 5mm down a bit. That's something to consider later. But at the moment they're just touching. It'll still work. I've got like probably 1/2 mil sticking through the other side of the circuit board to solder to, so it is what it is. And as we can see, the voltage has slowly dropped off from 11.24 to 11.20. So as I've been standing here talking, that's been slowly coming down. But I can't feel anything heating up, so it's not oscillating. So all well and good. So it's starting to come up a bit. So I'll leave that sit again, as I said, for a few minutes, and then I'll come back and we'll check the bias adjustment. Okay, so after a few minutes it's dropped off a little bit. So now I can just give that a little touch in the clockwise direction, just to bring the voltage back up a little. And I'm going to park it around about there somewhere. That should be close enough for the purposes of what it needs to be. Right, so now we'll take this resistor out of the fuse holder, put the fuse back in. Well, the fuse wasn't in to start with. I'm going to move my leads across the output, and I'm going to come around and disconnect the meter from the resistor and the leads and connect the meter up to the output of the amplifier, and we're going to look at its DC offset, which even with it turned off is considerably low. Alright, contact. Oh, that's fucking beautiful. We're looking at about 0.6 millivolts there. That's awesome. That's better than expected. So, if I go to the millivolt scale, Well, actually, there's more like 50 millivolts. Yeah, that'd be right, because I was reading the scale wrong. My apologies. Yeah, it's 46 millivolts, not 4 millivolts or 6 millivolts, whatever I said. Learn to read the scale properly, Astro. Anyway, even still, 60 to 40 millivolts DC offset, and it's falling, but it's coming back up again. It seems to be stabilising around about the 41 mark. That's pretty good. So if I touch the input, we should see that the voltage jumps around all over the place. That means that, well, the amplifier is amplifying a blurt. Therefore, we have an amplifier that's amplifying. So I'm going to say that the amplifier's nominal DC offset is going to be around about 38 to 45 millivolts, which is perfectly fine. As I say, on the plus minus 35 volt rails, might be slightly higher, but I know that it's functioning. Next step is to hook it up to an oscilloscope and dummy load and DDS, and we'll just have a look at the output sine wave just to see that the modification of that negative feedback resistor didn't affect the overall distortion of the amplifier. Alright, got all the test equipment set up, got the DDS on 1.3 volt peak to peak, 1 kilohertz. Got the DSO hooked up to the output, so I'm just going to turn the load on. And as we can see, we've got a nice clean sine wave. There is no evidence of distortion where negative feedback is not working correctly or not enough is being applied. Now, why is that so? Well, just like an op amp, a discrete power amplifier using a long tail pair as an input stage will always try to make both inputs the same, regardless of the resistance values. And that's exactly what it's doing here, and why we still have a nice clean output, but we now have a lower DC offset. Okay, so just for shits and giggles, why not? Let's go into a sweep mode and we'll have a look at our frequency response, shall we? And we're still pushing around about 38 to 39 volt peak to peak out, like we were before. Even with the other output transistors, makes no difference. Starts rolling off at about 36 volt now, towards the 19 kilohertz. It starts off around about 38.5. That's all well and good. That's beautiful, that's great. I'm happy about that. Go back to continuous mode. So, heatsink's getting mildly warm, but it is trying to pull the board forward, all these fly leads. The output devices are warm, but that's okay. Okay, so turn that off. And now the next thing to do would be to hook it up to the transformer, power supply module, DC speaker protector, and preamplifier. But I think I might just hook it up to just those three items first: the transformer, power supply, and speaker protector, and we'll see what we get. Alright, now it's hooked up to an AC transformer. Let's see what happens. Hopefully nothing goes off with a bang. If it does, it'll be spectacular. But this is the first time that this power amplifier will be running off of an AC smoothed DC supply. Well, apart from the power supply. Well, okay, there is a buzz there. But it is working. As to why there's this buzz, well, I reckon that's because of where I decided to ground the amplifier. Hang on just 2 secs. Okay, well, I've moved the grounding point for the 0 volt rail of the amplifier to the 15 volt 0 reference, which is after the filter caps. I had the DC speaker protector connected across this point, and then that was connected back over here. Then that was connected to the ground of the transformer, or the center tap of the transformer, which is wrong. So, well, there's still a buzz there. Not entirely sure why. So let me move this output wire away from there. Right, well, that's not behaving properly. Alright, so I want to know if that's the speaker protector module doing that, or it's the amplifier. So what I'll do is I'll disconnect the speaker protector out of the circuit, and well, supposed to get the speaker to work, I'll just simply connect the two together here at this point, and we just disconnect the AC wiring. And well, I do have my speaker output ground there too, so that's not a good place for it. So I might actually ground that back at the amplifier itself. Okay, so the AC is disconnected, so it will make a huge thump. It wasn't as bad. But no, there is no mains buzz there. So I'll reconnect the speaker protector into circuit here. Okay, that's back up. Oh, that's better. Yes, the positioning of your grounding points is very important. I had the speakers ground right at this point here, which is where the 0 is for the speaker protector, which goes absolutely nowhere near the star earth point, which is actually technically at this power amplifier point here. So yeah, your grounding points where you decide to take grounds off of is very important. But now that's working fine. There was a little bit of a noise when the speaker relay engaged. Let's see if we can make it do it again. There's a little... That's fair enough. Okay, so all that circuitry is functioning fine together. So now I might hook up the preamp to the power supply and yeah, see how we go. Well, the preamplifier is hooked up to the power amplifier and the power supply, so we're now going to see if it makes any strange noises. I believe everything's connected the correct way round. Yep. There's no strange noises, except on the roof. Okay, so I need to plug in a audio lead to one of these inputs, just so that I can touch the end of it and see if we get any noise. So I'll plug it into the guitar input. Okay, very good. So I need to find something to hold this lead in place so it doesn't pull the whole entire contraption off the desk. Okay, that's where a pair of pliers often helps. Okay, that works. I don't really want to do it for too long because that's the transformer in this test amplifier that I'm using, the 18018, is only rated at about 1.5 amps, so it's not quite substantial. I am picking up a bit of a buzz. I reckon that's coming from all the leads and shit going everywhere. But it is working as it should, and it's all now working off of an AC transformer, as it will do in the final design. And no, clunky bidirections and groove is not the only thing I know how to play. It's just the most convenient to play. So that's pretty much leaves me. I'm just checking the temperature of the heatsink on the speaker protector. It's reasonably warmish, almost hot. Probably looking at about 40 degrees there, somewhere around there. The reason why there's that little slight mains buzz when it first engages the relay is because, well, I've got the output grounded to where the ground is going back to the center tap of the transformer. So that's on the unfiltered side of the mains secondary. It should actually be going a separate ground running up to the speaker protector, which is going to the star earth point on the DC ground side. But that's the only reason it does that. It's not a great issue. It is a little bit annoying, but yeah. And currently the preamplifier is running on plus minus 16 volt and is quite happy. I'm also happy. I'm just waiting on a rack case so I can mount all this shit. I've also ordered a power transformer. I don't know if I said that in the beginning of the video or not. I did now. So I'm waiting on that, and then I can start putting this all in a case and you know, making it into an actual amplifier. But this is a good way of testing whether things have got grounding issues or are going to work properly. It'll work a lot better when it's sitting in a case, and those regulator ICs aren't even really getting warm, so that's fine. So yeah, I'm going to leave this video here. Thank you for watching, and as always, if you enjoyed this video, please remember to rate, comment and subscribe below, and you can always follow me on Facebook and Twitter. The links are in the description as usual. Anyway, this is the Astro 30 saying Merry Christmas.